Right, for our next review problem, we're going to try to factor this cubic function. It's not really a function because we haven't declared it such, but one thing to notice, and always look for this in your cubic functions, is the relationship between the first and the second, and the third and the fourth term. Here it's a ratio of 1 to negative 3, negative 7 to 21. That's the same ratio if you reduce it. Now, if those ratios are in fact the same, then that means that we can factor it by grouping. So the way we factor by grouping is we isolate the first two terms. You don't have to do this, but just to make it crystal clear, I'm going to break them up into two different parts. Now, each of these binomials has something in common. This has an x squared that we can factor out. And when we do so, we will have an x, because x cubed divided by x squared is x, minus 3, which is 3x squared over x squared. Over here, you always pull out the sign from the first of the binomial. So if this were a positive, we would pull out a positive. It's a negative, so we have to pull out a negative. Now negative 7x and 21 have a common 7. So we're going to pull out a negative 7. And that will leave me with x minus 3. Now, if I hadn't pulled out that negative, this would have been negative x plus 3. So that would not allow us to proceed. In order for this method to work, we need the same binomial twice. Since both of these terms, now that we have two terms, have the same factor, x minus 3, we can pull that factor out. So we have x minus 3 times whatever is left over, which is x squared minus 7. Now, x squared minus 7 is prime because there is no perfect square. If this were a 4 or a 9 or a 1 or something along those lines, we could factor it further into a difference of squares, but that's not the case. So we are done with this factorization.